In the previous video, I introduced you to the idea of the acceleration. In this video, we're going to learn how to determine the sign of the acceleration, that is, whether the acceleration is positive or negative, and also the direction of the acceleration. We're going to start by making a connection to velocity. So here I have a car moving to the right, and the speedometer of the car reads 30 miles per hour. Here I have a car moving to the left, and the speedometer of this car also reads 30 miles per hour. So see if you can just write down what is the velocity for each of these cars. Okay, so for the car moving to the right at 30 miles per hour, we would say the velocity is 30 miles per hour. For the car moving to the left at 30 miles per hour, we would say the velocity is minus 30 miles per hour. In other words, the sign of the velocity is determined by our choice of the positive direction for the x-axis. You can see that we have already picked the positive direction for the x-axis, in other words, to the right, as usual. Once we have already picked the positive direction for the x-axis, then any object moving in that direction is said to have a positive velocity. Any object moving in the opposite direction is said to have a negative velocity. Now, the same idea applies for the acceleration. So let's say that again, we put our plus x direction to the right. And let's say we have two cars again. So this time I'll use different colors. Let's say we have a purple car here and a red car here. And let's say that our purple car is accelerating to the right. If the purple car is accelerating to the right in the positive x direction, we would say that the acceleration is positive. If the red car is accelerating to the left, in other words, accelerating to the negative x direction, we would say that the acceleration is negative. Now, this seems straightforward enough, but the real thinking is going to be in determining whether an object is accelerating to the right or accelerating to the left. Fortunately, for an object moving in a straight line, we have a straightforward way of determining the direction of the acceleration. So I'm going to give that to you now. Okay, so here is how we determine the direction of acceleration for an object moving in a straight line. If the speed of the object is increasing, then the velocity and acceleration of the object are in the same direction. In other words, if the object is getting faster, then the velocity and acceleration of the object are in the same direction. In other words, if the speed of the object is decreasing, or in other words, the object is getting slower, then the velocity and acceleration are in opposite directions. So we're going to do, so this may seem fairly straightforward, but it's extremely important, and this thinking is going to guide us through a whole bunch of different problems that we're going to be encountering in the course. So even though it may seem straightforward, we're going to do some exercises to practice how we think about this. Okay, so our first exercise, let's say we have the x-axis pointing to the right, and we have a car which is initially stopped at a traffic light, and then the light turns green. So I don't have a green pen, so I'll use blue. So we have car stopped at a traffic light. The traffic light turns green, which I'm showing here is blue. And for this situation, I would like you to draw in the velocity of the car and the acceleration of the car, and then see if you can specify whether each of those is positive or negative. So pause the video, try that, and then rejoin the video. Okay, so the car stopped, and then when the light turns, the car is going to start moving to the right. So the velocity is to the right. And since right is the positive direction, the car's velocity will be positive once it starts to move. Now, according to this, if the speed of the object is increasing, the velocity and acceleration are in the same direction. So since the car's speed is increasing, the acceleration is in the same direction as the velocity. So since the acceleration is now in the same direction as the plus x direction, the acceleration is positive as well. Here's a second little exercise. In this exercise, we have the car driving to the right, but the driver notices there is a duck crossing the road. The driver does not want to hit the duck, so the driver of the car is going to slam on the brakes. So as the car is slowing down, I would like you to draw in the direction of the acceleration and indicate whether the acceleration is positive or negative. So pause the video, try that out, and then rejoin the video. Okay, so here we can use this second line. If the speed of the object is decreasing, the velocity and the acceleration are in opposite directions. So since the car is getting slower, the acceleration will be opposite the velocity. So since I have my acceleration now pointing in the minus x direction, the acceleration would be negative. Here's a third exercise. In this example, we have an airplane which is pointed to the left, and the airplane's going to take off. So the airplane will be moving to the left and getting faster. So again, pause the video, draw in the direction of the acceleration, indicate whether the acceleration is positive or negative, and then rejoin the video. Okay, in this case, we have an object whose speed is increasing. When the speed is increasing, the velocity and acceleration are in the same direction. Since the velocity is to the left, the acceleration will be to the left as well. Now, is the acceleration positive or negative? Well, our plus direction is to the right. The acceleration is to the left. Since the acceleration is pointing opposite our positive direction, the acceleration must be negative. Okay? So here we have an example of an object which is getting faster and faster, but we say that the acceleration is negative because the acceleration is directed opposite of our positive direction. Okay, one last example. Here we have one last example. Again, the plus x direction is to the right. Here we have an airplane moving to the left, but the airplane is landing, so we presume it's getting slower with time. So again, pause the video. Indicate the direction of the acceleration and whether the acceleration is positive or negative, and then rejoin the video. Okay, so in this case, the object is getting slower. When the object is getting slower, the acceleration is opposite the velocity. Since the velocity is to the left, that means our acceleration is to the right. And since our acceleration is now pointing in the plus x direction, the acceleration must be positive. So here we have an object which is getting slower, and the acceleration is positive. In the next video, we're going to start moving towards solving example problems involving the acceleration.